Welcome everyone. Sorry for this little, hiccup, but we are there. So the agenda is, well, to provide you with an overview of what's new at Zemax, although Alper presented some of the updates already, especially regarding licenses.
I am glad to see that your Turkish is developing.
Yeah, well, thank you. Then I will introduce you to the key updates of the 22.2 or 22.2 updates for all the products. And then I will also give you a preview of an upcoming key feature, which should be quite interesting for a lot of users. And yeah, closing words at the end of the presentation. So what's new at Zemax? Let's start there. So, well, as you all know now, Zemax is now part of ANSYS for about a year now. And this means that there is really a potential to use different products to expand the kind of system and designs you can tackle with ANSYS products. So if we focus on the optics portfolio, we have now numerical, Zemax, and Speos, so you can really design systems from a very small scale, sensors or micro lenses, use Zemax products to design the optical system itself, and then use Speos for perception or full system simulation. So it opens up a lot of different possibilities. I won't list them all here because the ANSYS portfolio is pretty large. I think we have like 80 plus different software packages. But so of course it started like the integration. If we look from a Zemax product point of view, it started quite well with the STAR module, so that bridges the gap between FEA tools and OpticStudio. So we have a specific link from ANSYS Mechanical to export the data natively to the STAR module. So it really integrates pretty well in the stop workflow that you may want to use, but it can also create, new possibilities, for instance, for a full camera simulation workflow. So once you have designed your system in OpticStudio, you can then export the optical system to Speos, and then Speos can, well, simulate the whole environment and also the human eye perception, and also combine those results with the exact sensor behavior that can be also simulated in numerical with one of their packages called Charge. And then you can have access to the exact quantum efficiency or response of the sensor and combine that to simulate the exact raw image you would have with an actual camera. And Speos can also take into account motion blur and other effects that do happen in real life. So you can really simulate the whole system with a pretty high level of accuracy. That being said, so to integrate into the ANSYS ecosystem and to align with the ANSYS licensing options, we have introduced so a few months ago, new products, so new ANSYS Zemax products. So there is now an ANSYS Zemax OpticStudio, or AZOS, that is equivalent in terms of features to Zemax OpticStudio 22.2. So we now have the ANSYS and the legacy, let's say, OpticStudio software packages. Very similarly, we have the Optics Builder, well, the ANSYS Zemax Optics Builder product and the legacy Zemax Optics Builder as well. as Alper said, perpetual and subscription versions are available for, well, any of those packages and have identical feature sets. There's a new ANSYS license manager to align with the ANSYS licensing system, which is FlexLM. One of the largest change is that there is no more a single user option, or if I put it a bit differently, all the licenses are floating now with the ANSYS ecosystem. Plus, we have decided to kind of revisit the different editions that we offer. So yeah, you can see it by yourself. So we now have Pro, Premium, and Enterprise. Enterprise being Premium plus the Star module, which was previously licensed separately. To provide you with a complete view of, well, the transition period, so the final version of the legacy Zemax with new functionality will be January 2023. So there will be a 23.1 versions of legacy products. There will be service packs through, well, the whole next year, and so through the end of 2023. And there are migration promotions that are quite interesting from my standpoint. So please reach out to Eustace, contact Optophil to, well, have a specific quote about that. And yeah, that's where we are heading in terms of products and licensing options. That being said, all the new features that we have added and that we will add to the products are, I think, quite interesting. So let's revisit the key features that have been added. So to the legacy 22.2 version or the 22.2 version of ANSYS Zemax products. So we have continued to enhance the ray aiming feature, which is very important for any kind of wide angle system. So technically we have added support for different system apertures definition, just to, well, make it more robust and quicker with those types of system as well. One of the feedback we had also from the users is that the ray aiming part of OpticStudio was sometimes a bit difficult to properly set up because there are many different options out there. So in the 22.2 version, we came up with a ray aiming wizard that will help you determine what are the optimal settings. So the wizard will analyze your system and show you what are the recommended settings to make the ray aiming as efficient as possible. All right. Another OpticStudio/Star update from the 22.2 version is a new performance analysis tool. So you know that when you import structural deformations or thermal loads to your system using the Star module, you can analyze, well, use any of OpticStudio tools to analyze the impact on the optical performances. But what is also quite important to have a good understanding of what is happening in your system is also to analyze the contribution of each of those deformations or thermal loads, element by element, or even surface by surface. So thanks to the approach of the Star module, which adds actually a layer of information onto the surface SAG or the index material, you can do that by hand, but we came up with this new performance analysis tool that basically automatically does that for you. So it switches each of the FEA datasets on and off for each of the surface or each of the elements. And then you can analyze the impact in terms of spot size or wavefront error. You can focus on structural deformations, thermal load, so gradient index that is created by the temperature difference, or both effects at the same time, and show the error like surface by surface separately or in a cumulative way, which means you add the values from the previous surface to kind of see how the deformations pile up into your system. So, and then you have this kind of graph that is pretty straightforward to read. So in this example, you can see that, okay, you have some deformations on all the surfaces of your system, but really the worst offender, so which means the surface, the deformations that impact the optical performances of your system the most, is really on the first surface. So it helps you maybe focus on the surface to find out a solution to minimize those impacts if it creates a too large difference in terms of system output. All right. I forgot to tell you before I started, like every time, if you have questions at any point, feel free to ask them, interrupt me. I am very happy with answering questions on the go. So maybe you have questions already, or am I clear enough, maybe?
Let me also say, please feel free to ask in Turkish also. No problem.
Of course,
so
yes.
You can write from chat too if you have, like, if you want to prefer writing from chat.
Good point, Alper. Thank you. All right. So I'll take that as no question for now, and let me continue. So we have also added a tool inside OpticStudio to enable our users to export the OpticStudio file to SPIOS using the SPIOS lens system. So the SPIOS lens system is using a reduced order model of the current optical system. So it includes all the relevant parameters like deformations and so on. So through a SPIOS distortion file, and it's really a very quick way to, well, send all the relevant data to SPIOS to support any kind of possible workflow you would have between OpticStudio and SPIOS. So I showed you earlier one of the examples for a full camera simulation, but there are many different use cases where both tools can be used in conjunction. And so it's very important for us to provide our users with an automated link between those environments. Right, and this is one of the first, let's say, stones to a larger enterprise. We are looking also at other ways to improve the connections between all the tools, right? So if you think of numerical, for instance, there are already ways to exchange data through static files, but we are also working on a dynamic link between numerical and OpticStudio. So this is a very important topic for us, and yeah, I will probably have some quite nice information to share with you in our next virtual summit about that. speaking of connecting with other tools, it's also important for us to connect with CAD users and offer them, you know, options to work efficiently with CAD. So there are actually several options. So within OpticStudio, we have a dynamic link that allows you to use parts or assemblies from Creo or Autodesk directly in OpticStudio. So until now, we were only supporting Creo 4, so we have updated the dynamic link to support also legacy releases of Creo, so namely 4, 5, and 6, so as well as 7. And also to align with the supported Creo versions from Optics Builder. Speaking of Optics Builder, so the 22.2 updates came up with pretty nice updates as well. So until now, users were able to trace rays in Creo, so assess the impacts of the mechanical parts on the optical performances. But sometimes you need to be able to measure the distance between some rays and some parts, or use the rays to create some kind of baffle or mechanical parts. So on top of the existing reference geometry options, we have added clickable chief rays. So you can trace the chief ray into Creo, but also you can use that ray with any native Creo tools. So to measure a specific distance or use this specific ray as a reference axis to rotate a specific sketch to create a part, things like that. And very similarly, we have also added the option to create ray footprint boundary. So Optics Builder can create a sketch onto the surface shape that is also clickable. So you can use any of the Creo tools again to, well, measure a specific distance, create a part using those boundaries here. So to help the mechanical engineer properly package the optical system directly in Creo using Optics Builder. All right. Do we have any questions, Alper? Because since I have a single screen now, I don't see the.
Right now there are no questions. Let's pause for a minute. Soru varsa herhangi bir soru Türkçe veya İngilizce alabiliriz. Shall I ask maybe something or yeah, so right now the most sophisticated integration is achieved with Creo. Is that correct, Christophe? Maybe you can.
Yes, so it's correct. So Optics Builder, as of today, is only available in Creo. We are looking to expand Optics Builder on other platforms, but yeah, I cannot share additional information today. But yeah, we are looking at supporting other, CAD and environments, of course. And the OpticStudio Dynamic Link is working with Creo and Autodesk at the moment. Yes,
thank you.
Of course. So maybe I can switch on to the next part of the presentation. So it's a preview of an upcoming feature, should be available in OpticStudio 22.3. And it really links to our will to provide you with all the options to efficiently design for manufacturability. So actually, so you can see that there will be yet another update this year of our product line. So the 22.3 version, because 3 updates a year was our pace, the Zemax pace. The ANSYS updates plan is 2 times a year. So we will, from 2023 onwards, provide our users with 2 updates a year, but exceptionally this year you will have another update yet. So should be available early November with the information that I have today. And so before I jump into the composite surface details, let me quickly remind you of why design for manufacturability is important. Well, simply because well, you need to assess how your system will behave in real life when actually manufactured to make sure that it will meet the optical performances goal. And this has been a very important topic that we have been working on for some time now. Let me quickly remind you of some of the key updates that we have made along the latest updates. So end of 2019, we have introduced high yield optimization. So it takes into account the sensitivity of each of the surfaces during optimization. So before you even go into the analysis of the system using our tolerancing option, you can ask OpticStudio to find for you the best balance between optical performances and robustness of your system. We have also added tolerance presets, quick sensitivity, quick yield to provide you with a quicker and more efficient workflow to have access on those manufacturability results. And we have also updated the way we present the results from the tolerance process. We have also added new operands to also provide you with a more efficient process. And so where are we now, let's say, and what raises potential issues when you want to design for manufacture some optical system? Well, we have no built-in way to tolerance irregularities beyond standard and A-spheres. So there are different options out there. So you can use well, you can add a phase surface manually. So you can also simulate irregularities on other types of surfaces, but it's not built in. And we know that our users are looking for a very easy to use and automated workflow, because it's well, it's simply more robust. There is no manual step that you need to go through, and as we all know, manual steps can cause also errors. Similarly, there is no easy way to add measured data to any surface. And well, I have listed there are some applications, but virtually any system that is designed with OpticStudio is at some point hitting that kind of issues. So from cameras to aerospace applications, cell phone lenses, virtual or augmented reality applications, freeform surfaces, of course, lithographic systems, and I'm pretty sure we could expand that list. So our goal with this new update is really to build a robust method to add perturbations or measurements to any surface in OpticStudio sequential mode, and make it easy for you to do so. Also, it means make the perturbations accessible and visible in the lens data editor. and provide you with the with an easy way to analyze and understand those perturbations. So perturbations, as we see it, can include surface irregularity on any surface. So actually either simulated or measured, stop deformations or stop thermal data. In a way, it's what the STAR module is already doing. And also provide you with an option to easily include simulated or measured mid-spatial frequencies. So especially for freeforms and diamond turning manufacturing, you have all those ripples that are created by the manufacturing process that, well, you may want to be able to simulate to properly understand the impacts on your optical system. So I have included some, screenshots here of what kinds of shape you are now able to simulate, but it's virtually any shape. Why? Because of, I should say, thanks to our new composite surface. So the principle of the composite surface is pretty simple. It allows you to add the sag, so the shape of one surface to the next surface. So as you can see here, you can combine an even A-sphere and a Zernike standard sag. But you can, so yeah, I have additional options in the next slides. So just to be exhaustive on the principle of the composite surface. So it does not participate in the ray trace itself. So it's not a standard surface, if I should sum that up pretty quickly, but the sag of the composite surface will be added to the surface that follows the composite surface. So it's really one of the components that is being combined with the other surface sag, and it really allows you to create well, quite complex shapes in a very easy way. And it works with any surface with a real sag. So it wouldn't work with a phase surface, but it works with any sag that is described by an actual surface shape. So including grid sag surfaces, true freeform surfaces, Zernike standard sag, you name it. Extended polynomials, well, any surface with a real sag. What is also quite interesting is that you can stack any number of composite surfaces, right? So there is no limit in terms of number of composite surfaces that can be added to a base surface. And so the layout plots draw the total sag of the base surface. So the combination of the base plus the composite surfaces. And what's also pretty neat is that when you are using the sag map, so the analysis tool that shows you the exact shape of a surface, you can either plot the composite surface separately. If you plot the base surface, it will show you the combination of the base sag plus the composite surfaces. So you have basically access to all the layers separately to fully understand how your system is set up and what are the contributions of every base surface plus composite surfaces. Why is it extremely useful, especially for tolerancing? Well, simply because it can allow the TETSI tolerance operand to add a Zernike standard SAG to any type of base surface. So previously, this operand, which is adding Zernike standard SAG terms, could be used only with standard surfaces, even A-spheres, and toroidal, and of course, Zernike standard SAG surfaces. So now it can be used with any type of surface, and it's done automatically through the tolerance tool. So it's really a very efficient way to add perturbations to any surface in your system. Do you have any questions maybe about those composite surfaces?
No questions at chat.
All right, which means I have been clear enough, hopefully. And so, yeah, this is a pretty major update, the way I see it, and it will really provide our users with more flexibility, not only to define the system, but really also to assess the real life performances of the system. So I've focused here on tolerancing, but in a very similar way, you can also add very easily measured data as well in the exact same way. And so, yeah, it's quite powerful to understand how the actual system behaves. So, well, that was all I had on my end regarding information I wanted to share with you today. As I said, you will have a new update, should be around November this year, with, well, additional new features. And yeah, we're also looking forward to add exciting new options in the next releases as well.
Thank you very much, Christophe. Let me send an applause on behalf of everyone. So it was great to hear the integration developments between three optics and photonics products of ANSYS now, right? So Speos, Zemax, and Numerical will be more integrated in time, and we are excited to hear next developments in next meetings. And also the Dynamic Link CAD, actually Yiğit Uysal'da two talks after this will go over examples in which Dynamic Link is established between Autodesk Inventor and OpticStudio. So he will do hands-on examples, so it will be a good complement to this talk. And it's great to see also the manufacturability, performance skills being increased in OpticStudio.